In this video, we'll be talking about properties of exponents. You've already had experience with exponents, but let's review a little bit. 2 to the third, remember, just means 2 3 times. So any time you have anything to the nth power, that means that thing n times. The product rule, a squared times a to the third, that means you'll have 2 a's and then 3 more a's. So those will add up to give you 5 a's. So the product rule just says to add those exponents. Now there is a trap in the product rule. Look at this, 2 to the third times 2 to the second times 2 to the third. Is that going to be 4 to the fifth, or is it 2 to the fifth? Well, let's calculate it on the left. So that's 4 times 8, or 32. Now what is 4 to the fifth? 1026. So the answer is actually going to be 2 to the fifth. So you need to always remember that the bases are going to stay the same. Remember, your base is actually this number on the bottom. We also have what I call the peeping Tom rule. Most other math folks call it the power of a power, the power of the product. But I call it the peeping Tom rule, because we have this peeping Tom right here, looking in the window. Now notice that's a squared to the third power, so we're going to have 3 a squareds. So the answer is going to just be a to the sixth. So what do we do to those two exponents, the 2 and 3, to get 6? We just multiply them together. So that is called the power of a power rule. The next one is basically the same rule. You still have your peeping Tom, but they call it a different rule, but it's the same thing. So now your peeping Tom, instead of looking in on a single bed, is looking in on a double bed, but we're still going to multiply those exponents together. So you'll get a to the sixth times a to the ninth. That's called the power of a product rule. We also have the quotient rule. So if I had x to the fifth over x to the third, that means we're going to have 5 x's on top and 3 x's on the bottom. So we're going to cancel these out. Notice how many we have left over. So the answer is going to be x to the second. So look at your exponents. What do we do when we have a division? We're actually going to subtract those exponents. Now the zero rule. Now you can have your students just memorize this, but I like to have my students understand why the rule is the way it is. So if I have x to the third, that means I'm going to have 3 x's on top, 3 on the bottom, so everything cancels out. Remember what happens when everything cancels out? You don't get 0, you get a 1, like 2 over 2 would cancel out to give you 1. Okay, now let's look at another way that we could solve that problem. X to the third over x to the third. Remember we said you subtract your exponents? So that would be x to the 3 minus 3, or x to the 0. So since I started off with the same thing, then my answers should be the same. So anything to the 0 power is just 1. So let's work a couple of examples. 2x to the fifth raised to the seventh is to the 0 power. Well, that's just going to be 1. What about a smiley face to the 0 power? That's 1 too. Again, anything to the 0 power is going to give you 1. So now let's work a few problems that are just mixed up. So we've got 8 to the second times 8 to the third. Remember, when you multiply, what do we do to those exponents? We're just going to add them, but the key is the base must stay the same. There's a couple of tricky problems in your homework, so this is one of them. 3 to the fifth times 12 to the fourth times 4 to the fifth. We can split the 12 to the fourth up into 3's and 4's. So now notice we're going to have 3 to the fifth times 3 to the fourth, so that will be 3 to the ninth, and then 4 to the fifth times 4 to the fourth, so that will be 4 to the ninth. 7 to the fifth divided by 7 to the second. Remember, we're just going to subtract those, so we'll get 7 to the third, and then the last one, anything to the 0 power, is just 1. So I'd like you to do these three to hand in to class.